In our last video, we created a series of functions to be able to return multiple values using a single lookup function. It involved filters, it involved biro, it involved text join, and it was all done manually. And in the end, we created a function called XLOOKUPs. But the XLOOKUPs part had already been written. In this video, we're going to go through how to actually build that XLOOKUPs Lambda function. Lambda is an incredibly exciting part of Excel and Excel automation. Are you excited? Let's go!
This video is all about building a Lambda function. We'll be building a function that we used in a previous video on how to create a function which returns multiple values from a single lookup. I'll include that in the video description. While we can build Lambda functions using the name manager, it's best to use the advanced formula environment. To get it, first we go to add-ins. Then, we'll select more add-ins to get to the add-in store. So, to get the required add-in, we'll search for Excel Labs. That includes multiple new functionalities, including the advanced formula environment. And it's the first one on the list. When we're here, we click on the Add button to add the Excel Labs add-in into Excel. We can close the window now. And then we can see that Excel Labs is now available at the end of our home menu. There are a few options in Excel Labs. We're already in Functions, which is the tab we need. At this point, we click the plus button to add a new function. First, we add the name of our Lambda function, that is, XLOOKUPs. We can add a description to our Lambda. This will appear when you select the function, but it's completely optional. We'll add a quick description of what our Lambda does here, just to make it easier later. Before we get started on our formula, we add our arguments. These are the elements that we can use in our Lambda formula. We technically don't need any, but almost every Lambda will have at least one. Our first will be the lookup value. That's what we're looking for. Once we've typed that, we press Enter, or we click somewhere outside the box. Our next two variables are the lookup array, that's where we're looking for the value, and the return array, that's where we'll be getting the values from. Now, the next variable starts with a square bracket. This is because, unlike the other variables, we can leave this one blank. This will show an error that it contains unexpected characters. This is expected, since it is required for optional parameters. We're going to make this variable for the delimiter, which we'll customize later. We'll also add a second variable for not found. That is to say, what we want the formulae to show if the function doesn't return any value. Now, we start writing the formula itself. We'll start with a biro, since our formula could take a single value, or a full array of values. The formula starts with the lookup value variable to tell the formula what to look up. Next, we build a new lambda within the existing lambda function. This new lambda will start with row, and that word row is just a variable to say we're looking at a row within our lookup value, which could be an array. Within the lambda, we'll add a text join function. Unlike when we built this function earlier, in this case, we have a custom delimiter. That is, we can have a different value separating each value we return. To set a default, we add an if statement, and we use the isBlank function with our delimiter variable. So, if there is nothing available as a delimiter, we can add our default, which is comma, space. And if there's something, we have our delimiter variable. The next variable is, if there is blanks, we add a true. Finally, we'll be adding our filter function. We'll be filtering our return array, which are the values which we're looking to join. And we'll be filtering against our lookup array, the values we're searching for, and it's against the row, which is the specific element within the set of values which we chose to look up from. We finish the filter off by adding an additional clause to customize our message in case the filter doesn't find anything. If our not found variable is not used, it enters not found. Otherwise, it will use what was entered in the not found variable. Once you're done with the formula, click the Save icon. This will copy the formula you wrote to the sheet, and you won't lose all your work. At this point, we're done. And we can see our formula. Now, we're going to see XLOOKUPs in action. We'll start by creating a unique list from our EV car sales brand table. The XLOOKUPs formula is now available in the formula list, with the 5 variables that we created earlier available for selection. First, we'll select F3, hashtag to get our unique car values. The lookup array is our brands from the car sales table, and the return array is the model from our car sales table. When we close the formula, we can see that it's returning multiple values for every value. But let's say we want to change the separator. We can do that by going back into our formula, and we'll use a / instead. Now, instead of commas, we have 4 slashes. Finally, we'll go in and see where our Lambda formula resides in the sheet itself. It's under the name Manager. And we can see that there's a name of XLOOKUPs. When we click on Edit, we can see the entire formula we just entered. You can do formulas this way, but the advanced editor is strongly recommended. The Name Manager approach is very challenging for Lambda formulas that are more than just a couple lines and is very difficult to debug. So, I'd strongly suggest use of the Advanced Formula Editor whenever writing lambdas. Over this video, we've built a new function using Lambda, the XLOOKUPs function, which is one that I'm hoping that you'll be able to use in your own spreadsheets in the future. We also used the Advanced Formula Environment, a critical tool in building more advanced Lambda functions. If you like this video, please throw it a like. And if you have any questions, I'd love to see them in the comments section. Thank you for watching.